Okay, let's unpack this. We're starting today not with code, but with a universal feeling of dread.
Right.
That sinking, agonizing knowledge you get when you're 3 hours into debugging a complex script. And you realize the time you're spending is not productive. It's pure professional debt.
Oh, yeah.
It's a time that traps really talented people in this low-leverage cycle.
It's the moment when you look at the clock and you realize you've spent the equivalent of, I don't know, a small consulting project's worth of time just trying to figure out why your volatility calculation is off by 3 standard deviations.
Mm,
That is the cost of an unstructured, frantic workflow. That's really the agony at the heart of the freelancer's trap.
exactly. And our mission today is to transform that agony into architecture. We're going to eliminate those bad hours by shifting your focus from, tracing semicolons to actually commanding intelligence.
And we're doing this by looking at what's quickly becoming, I think, the definitive playbook for leveraged software creation.
Our source material for this deep dive is a privileged look inside an upcoming unreleased book, a true architect's manifesto titled Boring Problems, Big Money.
It really is.
And we just want to offer a massive and a sincere thank you to the author, the ex-freelancer, who built this methodology and, well, allowed us to share this architectural blueprint with you.
It's a huge deal. This isn't theoretical academic work or anything like that.
No.
This is the definitive guide to escaping what he calls the linearity wall, shifting from the fate of the talented slave, trading time for money, to selling compounding, repeatable software leverage.
And our mission is singular.
It really is. It's to show you how to transform your workflow from that of a stressed, high-priced laborer into a profitable, leveraged, AI-powered spreadsheet architect.
And the centerpiece of this whole transformation is it's a radical management technique. We're
Right.
talking about effectively hiring a chief technical officer, a dedicated technical contractor, for just under $20 a month.
$19.99 a month, yeah. Using the consolidated Google One AI premium arsenal.
And then, crucially, managing that contractor so effectively that you can build enterprise-grade software. I mean, validated, secure, robust software without ever having to write complex, fragile syntax yourself.
And that management, it all starts with the foundational principle of all scalable architecture. So we are jumping straight into one of the most powerful, high-impact tools in that architect's arsenal.
The logic isolation principle. Okay, let's unpack the pain point here with speed and the required amount of cynicism.
Let's do it.
If you are building complex Google app scripts today, and I'm talking things involving APIs, data transformations, proprietary formulas, did you know the #1 reason those scripts fail in production isn't a simple syntax error?
No.
It's not a misplaced bracket.
It's a fundamental flaw in the math, the underlying algorithm or the business logic. That is the core finding of the book. The execution environment, app script, is rarely the source of the high latency failure.
It's the flawed thinking.
It's the flawed thinking, exactly.
And that flawed thinking leads directly to the trap we just mentioned, the agonizing 14-hour debug spiral. The freelancer, who is paid by the hour, is just stuck. They spend 2 entire days debugging a script in the Google Apps script environment, tearing their hair out over array indexing or some missing semicolon.
2 days.
2 days, only to discover hours later that the bug wasn't code at all.
It was in the formula for the rolling average calculation, or the way they implemented the weighted moving average. The logic was wrong.
The math was bad.
The math was flawed. And they just spent 2 days trying to find a syntax solution to a logic problem.
Okay, I have to ask you, why is the app script environment so uniquely bad for finding logic errors? Why does it lead to this spiral?
So it boils down to the V8 runtime in the workflow. I mean, AppScript is optimized for execution, not for debugging.
Right.
When you run a function, it's compiled, it lives on Google's serverless infrastructure, and when you try to see what's going wrong, you're just relying on logs.
Waiting for those logs to populate.
Waiting for logs, restarting executions, trying to step through code line by line. It's notoriously slow. It's opaque, high latency.
Compared to what, like a local development environment?
Oh, absolutely. You spend 90% of your time just waiting for the environment to tell you something you already suspected.
So the environment is the bottleneck, but the underlying flaw is mathematical.
Precisely. That's why the logic isolation principle is the critical aha moment for the architect. The goal is simple. isolate logical errors. Is the math correct? Is the algorithm statistically sound from syntax errors?
Is the JavaScript written correctly?
Exactly. If you can prove the math works outside that high latency environment, you eliminate the 14-hour spiral.
Okay, so how do we achieve that isolation? This is where the $20 CTO comes in, right? Using one of the most powerful tools in the arsenal.
The tool is the native Python sandbox, which is built right into the Gemini Advanced workspace.
Why Python specifically?
Because it comes preloaded with high-performance, industry-standard data science libraries. I'm talking about pandas and NumPy. Python provides an instant, visual, and reliable environment for proving complex math before you ever involve the finicky apps script environment.
Wait, hold on. Isn't Python for data scientists? I thought we were building enterprise apps script solutions. Why bring in a whole other language?
Because Python is the language of proof. For our audience, for the architects who need fast validation, pandas is just non-negotiable.
Okay.
You can load a data set, apply a complex statistical transformation, and visualize the result, like instantly.
You get immediate visual feedback.
Immediate visual feedback on the underlying logic. You are using the right tool for the right job. Python for logic validation, app script for deployment.
Okay, let's make this real. The source material has a key example for this, proving a complex algorithm.
Yeah, so imagine an architect is building a portfolio tracker for a client. The client needs a specific custom calculation of financial risk, say, calculating volatility across a 90-day rolling window. This requires calculating things like the interquartile range, or IQR, to identify market outliers.
That's tricky multi-step math.
It's very tricky. So the old Freelancer way was to write the app script, test it against sample data in the sheet, watch the result break.
And then spend a day in the logs chasing ghosts.
Exactly. The architect, on the other hand, embraces the logic isolation principle. They adopt the Python-first workflow.
So what's the first step?
Logic prototyping. The architect uploads a sample CSV of historical trading data, real, messy data, to Gemini Advanced. They prompt the AI not to write app script, but to analyze the data using its native sandbox tools.
And what's the specific command structure here? How do you talk to it?
It's highly focused on data science language, something like analyze this data using pandas. Specifically, identify the interquartile range for the returns column across a 90-day rolling window to flag volatility outliers.
Okay, and there's more to it.
Yeah, then you add, then visualize the distribution using matplotlib and output a filtered dataset showing only the outliers.
And what happens next? What does the machine do?
The Arsenal sandbox just executes the Python code instantly. It runs the logic, it generates a clean chart showing the distribution, and it provides a filtered dataset.
So you don't have to wait for logs.
No waiting. You have immediate visual proof, a chart, that the underlying statistical logic is sound on real data. If the chart looks wrong, you know the math is wrong.
And you fix the Python formula in 30 seconds, not 2 days in app script.
That's the whole point.
That is genuinely profound because you've moved the point of failure. You've guaranteed the math is right before you ever touch the deployment language.
Yes. And once that logic is sound in Python, the final step is a single leveraged command to your $20 a month CTO.
Right.
You instruct the AI, translate this IQR calculation logic, which you have just validated in Python, into an optimized Google Apps script function that operates on a 2D array, ensuring V8 compatibility.
Okay, let's pause on the jargon for a minute there. For the architect who might not be a career coder, what is a 2D array, and why is ensuring V8 compatibility so important for performance?
Good question. A 2D array is simply how Google Sheets passes data to apps script. Just think of it as the table rows and columns, the natural spreadsheet format.
Okay.
When you write app script, you want to grab the data from the sheet all at once as one big 2D array using methods like getValues. This is just vastly faster than processing data cell by cell or row by row.
Which is a common performance killer for beginners.
Huge performance killer.
And V8 compatibility.
The V8 runtime is Google's modern JavaScript engine. It's what powers Chrome and now AppScript. Asking the AI to ensure V8 compatibility forces it to use modern, optimized JavaScript syntax and data structures,
Which runs significantly faster.
and are less prone to subtle errors than older AppScript code.
So the final step isn't coding, it's what you call semantic compilation.
That's it. Gemini acts as a semantic compiler. It takes the proven logic in the language of data science Python and translates it into the optimized language of the Cloud V8-compatible AppScript. It handles all the syntax and array manipulation for you.
And you avoid the 14-hour debug spiral entirely.
You radically reduce development time and you increase the inherent reliability of the final product because the logic has already been mathematically proven. This is the definition of leverage.
That logic isolation principle, it sets the technical foundation. But as the book makes crystal clear, that level of leveraged workflow, jumping seamlessly from Python to AppScript, that's only possible because the architect has acquired the full suite of integrated tools, the arsenal.
This is the critical systems decision. The architect isn't just an orchestrator of code, they are an orchestrator of economics. The decision to acquire the arsenal signals the inversion of labor. It moves the founder from trading finite time for finite money to selling compounding leverage.
So let's recap the emotional and economic pain of the freelancer's trap, or what the ex-freelancer calls the linearity wall.
The linearity wall is that invisible ceiling you hit when your success depends entirely on your own labor.
Right.
If you're good, you charge a high rate, say $150 an hour. But if you land 3 massive clients, suddenly you're working 80 hours a week just to keep up.
Success means more hours, which leads to certain burnout.
Absolutely. You realize you are the high-priced architect, yes, but you're also the laborer who has to pour every single bit of concrete. You are the talented slave.
The eureka moment that defines the architect's shift is realizing you have to stop selling time service and start selling software and the underlying systems, leverage.
Exactly. And historically, that meant spending hundreds of thousands of dollars on a dev team or spending 5 years mastering every single programming stack.
The integrated AI arsenal changes that equation completely.
And this brings us to the forensic economic audit, which is brutally simple but often overlooked by solopreneurs. If you are trying to build robust microSaaS today, you are probably paying what he calls an integration tax.
Walk us through that integration tax. What is the cognitive and financial friction of using a fragmented stack of tools?
So the book details the high hard cost, which averages between, $72 and $82 a month of running disconnected tools necessary for this workflow.
Okay, let's break that down for the listener.
Sure. First, you need a high-performance LLM, the reasoning capability of a top-tier model, which often costs $20 to $30 a month minimum.
Okay, number one.
2, a hosted Python environment. To run that logic isolation we just talked about, to use Pandas and NumPy, you need a separate hosted notebook service like Colab Pro or an equivalent. That's another $15 to $30 a month.
Right. What's next?
3, external cloud storage. To upload large context files or data samples, like the client CSV for validation, you need secure, high-capacity cloud storage. Maybe $10 a month for AWS S3 or Dropbox.
Okay, and the last piece.
A code assist or autocomplete tool. Maybe you use a dedicated coding extension for syntax help, another $7 to $12 a month.
So we're at $72 to $82 just for the basic tooling before you even calculate the soft costs.
And the soft cost, the cognitive friction, is arguably worse. You're managing 4 separate monthly subscriptions, 4 different documentation portals, 4 separate API keys for billing.
And constantly making sure the data translates between them.
It just slows everything down. That is the integration tax.
Okay, so contrast that brutal reality with the arsenal consolidation.
The Google One AI premium subscription unifies everything we just described.
Everything.
It provides the high-performance LLM, Gemini Advanced, the built-in native Python sandbox for validation, and the required 2 terabytes of drive storage for context loading and data uploads, all for $19.99 a month.
That is a fundamental economic conversion. That's a 70–75% reduction in hard costs. And it completely wipes out the cognitive friction of managing 4 separate vendors.
And that economic shift gives us the title of this new working arrangement, the CTO Mandate. You have effectively hired a world-class chief technology officer for $20 a month.
So your job is no longer the laborer's syntax work.
No, your job is solely to manage this extremely powerful, ruthlessly efficient, non-unionized contractor.
But wait, if it's so cheap and so powerful, what's the inherent risk here? Isn't there a massive vendor lock-in? If Google changes its pricing or capabilities, aren't you now completely reliant on one system?
That's an excellent question, and the book addresses it head-on. There is always vendor lock-in when you choose an integrated ecosystem.
Of course.
But the architect calculates the risk-reward ratio. The cognitive and economic friction of managing 4 systems outweighs the potential risk of a single vendor raising prices today.
Oh, it's more.
Furthermore, because the architect's true value is in the specifications and the business logic, the System 2 thinking, they can afford to switch platforms if it becomes necessary. The leverage gained now pays for the potential migration cost later.
So let's define that new division of labor. If the machine handles the how, what does the architect handle?
The architect handles System 2 thinking. That means writing the specifications, defining the business logic, and enforcing security governance. That's what we need a license checker, and the why, because we need recurring revenue.
And the contractor, Gemini, it handles System 1 execution. Writing the syntax, implementing the functions, all the low-level mechanical details, the how.
However, this contractor has a critical, dangerous quirk. It is fundamentally sycophantic.
Sycophantic.
It prioritizes immediate, literal satisfaction over architectural soundness or security. It wants to please you now, even if that means breaking the system later.
That makes the architect's role in governance absolutely paramount then. That single-skill governance is the highest leverage activity in the entire workflow.
Absolutely. Let's revisit the security warning from the book. If the architect uses a naive prompt, something like, write a function to fetch my API key from cell A1 of the settings sheet, the AI will deliver syntactically perfect code. It works immediately. But that code is a catastrophic security vulnerability.
So tell us, what's the disaster scenario there?
Well, first, when you share that spreadsheet with a client or another team member, the API key in cell A1 is exposed immediately.
Right.
Second, and this is more subtle, if the key is hard-coded or accessed directly from the sheet, it can sometimes be exposed in the execution logs depending on the platform security settings. This is just a fatal flaw for enterprise software.
So the architect has to enforce the constraint, the security mandate, that overrides the AI's naive impulse.
Correct. The governance lesson is the architect must enforce. Never hard-code credentials. Use the property service for secrets management.
For our listeners who aren't deep in app script, what is the property service?
Think of the property service as a highly secure, persistent key-value vault, accessible only by that specific script. You store your API keys there.
So they're never visible in the sheet.
Never visible in the spreadsheet or the code itself. So even if the sheet is shared, the credentials remain secure, protected, and encrypted. That single moment, the choice to enforce a governance layer, is the difference between building a fragile, one-off script and building a professional, sellable software asset.
Since we now understand that our $20 CTO is sycophantic and its default is fast, System 1 thinking, the architect can't rely on vague requests.
No, absolutely not.
You have to use a precise, structured language to eliminate what the book calls the ambiguity gap and force the AI into robust System 2 reasoning. This structure is the golden prompt formula.
And the book emphasizes this. If you want enterprise-grade output, you must provide enterprise-grade input.
Right.
The golden prompt formula requires 4 non-negotiable pillars in every serious request: role, context, constraint, and goal. Miss one, and the quality degrades dramatically.
That sounds like a lot of steps. If I'm trying to move fast, why can't I just ask the AI, give me the script I need? Why do I have to use role, context, constraint, and goal every single time?
Because speed is useless if you have to spend days debugging the code later. The 4 pillars force the AI to reason architecturally before generating the code.
Okay, so let's start with role. Persona priming. This isn't just fluff, right?
Not at all.
How does setting a persona actually change the code output?
It establishes the expected quality and specialization. You don't prompt, write a function, you prime the model. Act as a senior Google Apps script developer and solutions architect, specializing in high-performance serverless add-ons.
And what's the tangible, measurable benefit of doing that?
It forces the model to include professional elements that directly impact the user experience and platform compliance. Specifically, it encourages the inclusion of JSDoc comments.
And those are the standardized tags above a function.
That's right, the ones that explain its parameters and return values.
And why does the architect care about JSDoc?
Because JSDoc comments are mandatory for custom functions to appear correctly in the user's spreadsheet autocomplete menus. Without them, your function is hidden. By priming the model as a senior architect, it knows to include this documentation, ensuring the final product integrates seamlessly into the user's workflow. It also forces the use of modern V8 runtime syntax, which, as we discussed, is required for maximizing performance.
Okay, so pillar number 2 is context. This is where the sheer power of the arsenal becomes, frankly, overwhelming. We're talking about the massive 1 million token context window, potentially up to 2 million tokens. Why is this capacity the true killer feature?
It solves what we call the lost reference problem. In older, smaller models, you could only paste a small function, say 50 lines, for the AI to fix.
Right.
But the model would instantly forget how that function connected to your global variables or your utility functions or API wrappers that are defined in the rest of your 10,000-line code base.
So the fix would inevitably break the entire system.
Exactly, because the AI lacked comprehensive situational awareness.
That is the essence of why large systems were always too fragile for AI development.
But now, with the massive context window, the architect uploads the entire project code base.
The whole thing.
We're talking code.js, utils.js, and maybe the full 500-page Stripe API docs.pdf hash, all uploaded and visible to the AI simultaneously.
That is incredible. The AI can see the entire blueprint.
It ensures referential integrity. When you instruct Gemini to refactor a pricing calculation function, it knows exactly which global variable is holding the API base URL, which dependencies are safe to touch, and whether a function has been defined elsewhere.
So this is absolutely essential for things like legacy migration projects.
Oh, absolutely. Converting a thousands-of-line VBA macro into a clean, modern apps script structure. The AI can manage the complexity and integrity of the whole system at once, saving months of human debugging time.
Okay, pillar 3, constraint. This is the architect's wisdom made manifest, the mandatory governance layer. This dictates the non-negotiable rules based on security mandates and hard platform limits, like the 6-minute wall.
The constraint layer is where the architect injects the painful lessons learned from past failures, ensuring the machine doesn't repeat them. We are forcing the AI to use enterprise architecture.
So let's look at the 3 mandatory constraints. Start with performance.
Okay. The constraint must mandate. Must use batch operations like set values and url_fetchup.fetchall to minimize latency.
Because of the 6-minute wall.
Right. The app's script environment has that hard limit, the 6-minute wall after which the script will terminate, regardless of progress. If the AI writes a sequential loop that takes 1 second per row to process 400 rows, that's 400 seconds. Manageable.
But if it processes 4,000 rows?
You hit the wall and fail. By mandating batch operations, you force the AI to grab or write thousands of cells in a single network call, keeping you safe from the execution limit.
Okay, next, security. We touched on this with the property service.
Non-negotiable. Use property service for all credentials. This constraint prevents the catastrophic security vulnerability of hard-coding secrets into the visible script or the sheet itself. The architect is always thinking about the worst-case scenario.
A shared sheet or a leaked code snippet.
Exactly.
And finally, resilience.
The constraint must mandate. Wrap all external network calls, url_fetchup, in robust try.catch blocks, and implement exponential back-off logic for 429 rate limit errors. If you are hitting a third-party API Stripe, Shopify, and internal license server, the connection will fail sometimes.
And a simple failure kills the script.
Then creates a bad user experience.
So what exactly is exponential backoff? That sounds technical.
It's just a smart retry mechanism. When the API server sends a 429 too many requests error, the AI's naive impulse is to retry instantly and fail again.
Right.
Exponential backoff means the function automatically waits a small random amount of time, say 2 seconds, then retries. If it fails again, it exponentially increases the wait time, maybe 4 seconds, and so on.
Until the request succeeds, or it hits a maximum retry limit.
Exactly. It transforms a fragile network call into a resilient production-grade connection, ensuring the script can survive the volatility of the internet.
The constraint layer, in essence, is where the architect dictates quality control.
It transforms a naive piece of code into a resilient production-grade asset.
Finally, the last pillar.
Yeah.
The goal. The atomic unit. We are requesting a single, testable vertical slice of the application, not the entire system at once.
The goal must be surgically specific. Never ask the AI to build the entire licensing feature. That introduces too much ambiguity.
So you focus on the smallest, most testable component.
Right.
Give us the command structure for the goal.
Something like create a function, check license status key, that uses url_fetchup to post the key to the license server, handles a 404 error gracefully, and returns a Boolean value, true/false, to the client side.
So you're separating the logic, the API call from the full integration, like updating the spreadsheet UI.
Exactly. It creates a small, testable piece of code.
By enforcing the structure, role, context, constraint, and goal, you eliminate the ambiguity gap, forcing the contractor to output a piece of code that is not only syntactically correct, but architecturally sound, secure, resilient, and easily debugged.
That is the leverage.
We've established the rigor of the golden prompt. But even with the perfect structure, the contractor, our $20 CTO, is useless if its foundational information is obsolete.
Mm.
This leads us to the final necessary piece of the architectural puzzle: context loading.
This is a fundamental vulnerability of relying on large language models. The knowledge cutoff. LLMs are trained on vast data sets frozen in time.
So the AI can't inherently know about new API endpoints, security compliance rules, or breaking changes introduced after its training period.
Right. The book calls this temporal amnesia.
So the AI is always operating on yesterday's facts. And the danger this presents is what the book calls hallucinated compliance.
And it's the worst kind of failure. The AI generates code that is syntactically perfect, it compiles, it looks beautiful, it has all the JS comments.
But it's functionally obsolete.
Exactly. Because the external service it's trying to communicate with no longer exists, or the required data format has fundamentally changed. It complies with rules that are no longer real.
The source material provided a really visceral example of this failure. Can you expand on that Amazon KDP publishing tool scenario?
Certainly. An architect built a sophisticated, high-volume publishing tool that automated the process of uploading books to the Amazon Kindle Direct publishing platform.
Okay.
The AI generated a superb workflow using the platform's API structure as it existed during its training window.
So what did the AI miss?
Well, Amazon, facing an explosion of low-quality spam books, had instituted a strict new unannounced policy limiting authors to 3 title uploads per day.
And this was introduced after the AI's training data cutoff.
Correct. The AI, blissfully unaware of the present state of the world, generated a workflow that attempted to upload 10 titles immediately.
Oh, the consequence must have been instant account suspension.
Exactly. The script worked perfectly, but it violated the rules of the platform it was designed for. The failure wasn't a semicolon, it was a knowledge deficit that led directly to account suspension.
Destroying the user's business credibility.
Their trust in the tool, the product's viability. The architect paid the ultimate price for the AI's temporal amnesia.
So the architect must manually inject the present state of the world into the model's working memory. This is the ArgLite solution.
ArgA stands for Retrieval Augmented Generation, but for the architect, we call it ArgLite. It's the process of uploading authoritative documentation directly into the chat session before generating code.
So this could be the full 500-page Stripe API PDF, a vendor's custom licensing API markdown file, or the latest Google Apps script deprecation list.
Yes, you are turning the vendor's own documentation into the AI's immediate source of truth.
Which makes the code generation grounded.
Precisely. The prompt then explicitly grounds the model in that authoritative truth. The command structure changes dramatically. You command, based on the Stripe API documentation provided above, write a Google Apps script function.
That opening phrase, based on the documentation provided, that's the critical architectural guardrail that mitigates temporal amnesia.
It forces the model to prioritize the information you just uploaded over its generalized, stale training data. This eliminates the risk of the AI hallucinating deprecated methods, ensuring the generated code is compliant and functional the moment you hit run.
It protects the architect from the inherent volatility of external vendor changes. But software is a living organism. API endpoints become obsolete, and those context files, even though they were the source of truth yesterday, they suffer from context rot. Doesn't this create a new liability? A false sense of security where the architect thinks the AI is using correct data when it's actually using a month-old PDF.
That is the final stage of maturation for the architect. You must manage context rot. You can't just upload the Stripe PDF once and forget about it. The protocol involves establishing an auto-update protocol.
What does that look like in practice for a solo architect?
It doesn't need to be complex. The architect monitors the key vendor changelogs, Stripe, Shopify, Google Workspace, and uses a simple monitoring script, maybe even a basic web scraper or an RSS feed listener, to notify them when a core API version or breaking change is announced.
So the architect builds a simple tool to feed their $20 CTO fresh information.
Correct. When a notification arrives, the architect generates a fresh context file, perhaps scraping the latest API documentation page, and uploads it immediately before any new work is done on that system.
The final repository of this up-to-date knowledge, the strikespecs.md, the gasv8rules.md, that then becomes the architect's most valuable asset.
It is the crystallized knowledge of the business domain, updated on the cutting edge of reality. It's the defensible barrier that separates the architect from a fast-following competitor.
A competitor can copy your app's script code.
But they don't have the constantly updated, grounded blueprint that ensures compliance and functionality today. They have the fish. You have the persistent fishing net and the knowledge of where the fish are running right now.
What a transformation of the modern workflow. We have spent this deep dive detailing the foundational architecture required to build scalable software assets today. We started with the psychological and economic pain of the linearity wall, and we found the solution in the logic isolation principle, moving the complexity of math into the Python sandbox for guaranteed logic.
We then calculated the tremendous economic leverage of hiring a 1999 CTO using the consolidated arsenal, eliminating that $72 integration tax, and we detailed the rigor of the golden prompt formula role context constraint goal to ensure that the code outputted by the machine is secure, high performance, and resilient against platform limits like the 6-minute wall.
And finally, we detailed how the architect must override the AI's temporal amnesia through context loading and the crucial practice of managing context rot, ensuring the code is not just syntactically correct, but compliant with the present state of the world.
It's all connected.
If you are going to escape the fate of the talented slave, you must stop writing semicolons and start commanding intelligence.
And the core lesson here is the speed of validated iteration. I want you to consider the economic difference between two scenarios. Scenario 1. A structural failure discovered and resolved in a 2-day debugging spiral, forcing you to refund a client or miss a deadline.
That's the freelancer's cost.
Right. Versus scenario 2. A logical failure discovered and fixed within the Python sandbox in 30 seconds because you forced the logic and the syntax apart. That is the architect's leverage. The speed of failure detection determines your sovereignty.
That is the ultimate trade-off and the key to building real wealth in this new economy. Thank you for diving deep with us today.
Yes.
See you next time.